In the vast expanse of our solar system, amidst the celestial dance of planets, lies Venus, our closest planetary neighbor. Positioned second from the Sun, Venus is often referred to as Earth's twin due to its similar size and mass. This enigmatic world, shrouded in a thick and toxic atmosphere, has captivated astronomers and stargazers for centuries. Despite its proximity and resemblance to our planet, Venus harbors a hostile environment that stands in stark contrast to the life-sustaining conditions on Earth. Nevertheless, this enigmatic world holds valuable clues that can deepen our understanding of planetary evolution and the delicate balance that makes life on Earth possible. Venus's orbit is closer to the Sun than Earth's, resulting in a significantly shorter year. It takes Venus only 225 Earth days to complete one orbit around the Sun. This means that a Venusian year is shorter than a Venusian day, as it takes Venus even longer to rotate on its axis. This slow, retrograde rotation, opposite to the direction of most planets in our solar system, is just one of the many intriguing characteristics that set Venus apart. Despite its alien nature, Venus has played a significant role in shaping humanity's understanding of the cosmos. Throughout history, Venus has been a prominent object in our night sky, easily visible to the naked eye. While Venus shares some basic similarities with Earth in terms of size and composition, it is anything but hospitable. Its atmosphere, composed primarily of carbon dioxide, traps heat with extraordinary efficiency, leading to a runaway greenhouse effect. This has resulted in a surface temperature that can reach a scorching 464 degrees Celsius or 867 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure on Venus is also immense, about 90 times greater than Earth's at sea level. This crushing pressure, combined with the extreme heat, creates an environment that is utterly inhospitable to life as we know it. The surface of Venus is as unforgiving as its atmosphere. Radar mapping by spacecraft has revealed a landscape dominated by vast plains, towering volcanoes, and impact craters. Volcanic activity has played a significant role in shaping the Venusian surface, with evidence suggesting that eruptions may still occur today. The atmosphere of Venus is a hostile shroud, a stark contrast to the life-giving air we breathe on Earth. Composed primarily of carbon dioxide, with a staggering 96.5% concentration, it acts as a massive thermal blanket, trapping heat from the sun and creating a runaway greenhouse effect. This dense carbon dioxide atmosphere is about 90 times more massive than Earth's, generating a surface pressure equivalent to being 900 meters or 3,000 feet beneath the ocean surface on Earth. Such extreme pressure would crush most life forms familiar to us. Adding to this toxic mixture are clouds of sulfuric acid, a highly corrosive substance. These yellowish clouds are not composed of water droplets like Earth's clouds, but rather droplets of sulfuric acid, reflecting sunlight back into space and giving Venus its high albedo or reflectivity. The greenhouse effect is a natural process that plays a crucial role in regulating planetary temperatures. On Earth, greenhouse gases like carbon dioxide, water vapor, and methane trap a portion of the sun's heat, preventing it from escaping back into space and keeping our planet at a habitable temperature. However, when greenhouse gases become too concentrated in an atmosphere, as is the case on Venus, the greenhouse effect can spiral out of control, leading to a runaway greenhouse effect. Venus's thick carbon dioxide atmosphere acts like a massive thermal blanket, trapping the sun's heat and raising the planet's surface temperature to an astounding 464 degrees Celsius or 867 degrees Fahrenheit. This extreme heat is hot enough to melt lead and is far higher than the temperature on Mercury, the closest planet to the Sun. The high temperatures are not just limited to the surface. They extend throughout the entire Venusian atmosphere, making it the hottest planet in our solar system, even hotter than Mercury, despite being farther from the Sun. The runaway greenhouse effect on Venus is a prime example of how a planet's atmosphere can dramatically impact its climate. It highlights the delicate balance of atmospheric composition necessary for a planet to maintain habitable surface temperatures. The extreme conditions on Venus serve as a stark warning about the potential consequences of unchecked greenhouse gas emissions on Earth and the importance of mitigating climate change. Venus, a glimpse into Earth's past. Looking at Venus today, a scorching inferno shrouded in toxic clouds, it's hard to imagine it as anything other than a hellscape. However, some scientists believe that Venus might hold a mirror to Earth's distant past, offering a glimpse into what our own planet might have been like billions of years ago. This hypothesis stems from the fact that Venus and Earth share striking similarities in size, mass, and bulk composition, suggesting they formed from similar materials in the early solar system. Could Venus have once been a more hospitable world, perhaps even harboring life in its youth? The evidence for this intriguing possibility lies in the faint whispers of ancient riverbeds and shorelines, etched onto the Venusian surface and detected by orbiting spacecraft. These geological features, now baked and distorted by eons of intense heat and volcanic activity, hint at a time when liquid water might have flowed freely on Venus, forming oceans and carving valleys much like those on early Earth. Some computer models suggest that Venus could have maintained a temperate climate for billions of years, with oceans potentially persisting for a significant portion of its history. However, this period of potential habitability, if it ever existed, met a dramatic end. Scientists theorize that a runaway greenhouse effect, triggered by a combination of factors including volcanic activity and increasing solar radiation, transformed Venus from a potentially life-supporting world into the inferno we observe today. A tale of two planets' divergent paths. Despite their shared origins and early similarities, Venus and Earth embarked on vastly different evolutionary paths, leading to the stark contrast we observe today. While Earth developed into a vibrant world teeming with life, Venus succumbed to a runaway greenhouse effect, transforming into a scorching, inhospitable wasteland. Understanding the factors that led to this divergence is crucial for comprehending the delicate balance that governs planetary habitability. One key difference lies in the geological activity of the two planets. Earth's surface is constantly reshaped by plate tectonics, a process where the planet's outer shell is broken into large plates that move and interact with each other. This movement drives the formation of mountains, volcanoes, and ocean basins, and it plays a vital role in regulating Earth's climate by recycling carbon dioxide between the atmosphere and the planet's interior. Venus, in contrast, lacks plate tectonics. Its surface is a single continuous crust that shows evidence of past volcanic activity but lacks the dynamic, constantly shifting landscape of Earth. Without plate tectonics, Venus was unable to regulate its carbon dioxide levels effectively, allowing greenhouse gases to accumulate in its atmosphere and ultimately contributing to the runaway greenhouse effect. Furthermore, Earth's magnetic field, generated by the movement of molten iron in its core, acts as a shield, protecting our atmosphere from the erosive effects of the solar wind, a stream of charged particles constantly flowing from the sun. Lessons from a runaway understanding climate change. Venus, with its extreme greenhouse effect, serves as a stark and sobering example of the potential consequences of unchecked climate change. While Earth's current climate is far more hospitable than Venus's, studying our sister planet provides valuable insights into the mechanisms of climate change and the potential for rapid and dramatic shifts in planetary environments. By analyzing the composition and dynamics of Venus's atmosphere, scientists can refine their models of climate change on Earth. The extreme conditions on Venus allow researchers to study the behavior of greenhouse gases at concentrations far exceeding those found on Earth, providing valuable data for validating and improving climate models. These models are essential tools for understanding how Earth's climate might respond to increasing greenhouse gas emissions and for developing strategies to mitigate the impacts of climate change. Moreover, studying Venus's climate history helps scientists identify potential tipping points in Earth's climate system. Tipping points are critical thresholds that, once crossed, can trigger rapid and irreversible changes in climate. By understanding the factors that led to Venus's runaway greenhouse effect, researchers can identify similar vulnerabilities in Earth's climate system and develop strategies to avoid or mitigate the risks of crossing such critical thresholds. Venus stands as a cautionary tale, a stark reminder of the potential consequences of unchecked environmental change. While the extreme conditions on Venus are unlikely to occur on Earth in the foreseeable future, studying our sister planet provides valuable insights into the potential for rapid and dramatic shifts in planetary climates and the importance of responsible environmental stewardship. By using Venus as a case study, scientists can develop and refine models that simulate the long-term effects of various climate change scenarios on Earth. These models can help us understand the potential consequences of different greenhouse gas emission pathways, providing valuable information for policymakers and stakeholders to make informed decisions about climate action. Furthermore, studying Venus's atmosphere helps us understand the potential for positive feedback loops in Earth's climate system. Positive feedback loops occur when a change in one part of the system amplifies further changes, leading to a self-reinforcing cycle. For example, as temperatures rise on Earth, ice caps and glaciers melt, reducing the planet's reflectivity and leading to further warming. Venus's runaway greenhouse effect is a prime example of a positive feedback loop in action. And understanding these processes on Venus can help us identify and potentially mitigate similar risks on Earth. While Venus's surface may be a scorching wasteland, its atmosphere offers a rich tapestry of scientific insights. Studying Venus's atmosphere provides valuable information for understanding atmospheric dynamics, chemical processes, and the evolution of planetary atmospheres not just on Venus, but on other planets, including our own. Venus's superrotation, where its atmosphere circles the planet much faster than the planet rotates on its axis, is a unique and intriguing phenomenon that continues to puzzle scientists. Understanding the mechanisms driving this superrotation could provide valuable insights into atmospheric circulation patterns on other planets, including those with slow rotation rates or dense atmospheres. Furthermore, the chemical composition of Venus's atmosphere, particularly its high concentration of carbon dioxide and sulfuric acid clouds, offers a natural laboratory for studying chemical reactions and processes relevant to atmospheric chemistry on other planets. By analyzing the interactions between sunlight, atmospheric gases, and cloud particles on Venus, scientists can refine their understanding of photochemical processes, aerosol formation, and the role of clouds in regulating planetary climates. Moreover, studying the evolution of Venus's atmosphere can help scientists understand how planetary atmospheres change over time and the factors that contribute to their stability or instability. In the vast cosmic ballet of our solar system, every celestial body, from the mighty sun to the smallest asteroid, exerts a gravitational pull on every other object. These invisible forces, governed by the laws of physics, weave a complex tapestry of interactions, shaping the orbits, rotations, and even the destinies of planets and moons. While the sun's immense gravity dominates our solar system, the gravitational interplay between planets, particularly those in close proximity, adds subtle nuances to this celestial dance. Venus, our nearest planetary neighbor, plays a role in this gravitational interplay, exerting a small but measurable gravitational influence on Earth. Though dwarfed by the Sun's gravitational dominance, Venus's pull on Earth is not insignificant. This gravitational influence arises from the fundamental principle that every object with mass attracts every other object with mass. The strength of this attraction depends on two factors: the mass of the objects involved and the distance between them. While Venus is significantly less massive than the Sun, its proximity to Earth amplifies its gravitational effect, creating a subtle but persistent tug on our planet. Most people associate tides with the moon's gravitational pull on Earth's oceans, causing the rhythmic rise and fall of sea levels twice a day. However, the moon is not the only celestial body that influences tides on Earth. Venus, despite its distance, also exerts a small but measurable tidal force on our planet. While these Venusian tides are significantly weaker than those caused by the moon, they contribute to the complex interplay of gravitational forces that shape Earth's dynamics. Tides arise from the difference in gravitational pull across an object. Because gravity weakens with distance, the side of Earth facing Venus experiences a slightly stronger gravitational pull than the side facing away. This difference in gravitational force creates a stretching effect, pulling Earth slightly outward along the line connecting the two planets. The gravitational dance between Venus and Earth extends far beyond the subtle tug-of-war that influences tides. Over vast stretches of time spanning millions of years, the cumulative gravitational effects of Venus can influence Earth's orbital and rotational dynamics, creating subtle but persistent rhythms in our planet's celestial motion. These long-term effects are particularly pronounced when the orbital periods of Venus and Earth align in specific ratios, leading to a phenomenon known as orbital resonance. Orbital resonance occurs when the orbital periods of two celestial bodies are related by a simple ratio of whole numbers. For example, Pluto and Neptune are locked in a 3:2 orbital resonance, meaning that for every 3 orbits Neptune completes around the Sun, Pluto completes 2. These resonances can have significant effects on the stability and evolution of planetary orbits. While Venus and Earth are not currently in an exact orbital resonance, their orbital periods are close enough to create subtle gravitational perturbations that accumulate over time. These perturbations can influence the shape and inclination of Earth's orbit, as well as the rate of its rotation. The gravitational relationship between Venus and Earth, while subtle compared to the Sun's dominance, highlights the interconnected nature of our solar system. Every object, regardless of its size or distance, plays a role in this intricate cosmic ballet, influencing and being influenced by the gravitational forces of its neighbors. This delicate balance of forces has shaped the solar system we observe today and continues to govern its evolution over astronomical timescales. Venus's influence on Earth, though small, serves as a reminder that our planet does not exist in isolation. We are part of a larger system, a celestial dance where even the slightest gravitational nudge can have ripple effects that propagate across vast distances and timescales. Understanding these interactions is crucial for comprehending the history, present state, and future evolution of our solar system. Furthermore, studying the gravitational interplay within our own solar system provides valuable insights into the dynamics of other planetary systems throughout the universe. As astronomers discover more exoplanets orbiting distant stars, understanding the factors that contribute to the stability and habitability of planetary systems becomes increasingly important. The lessons learned from studying Venus and Earth's gravitational dance can be applied to these distant worlds, helping us unravel the mysteries of planetary formation and evolution on a cosmic scale. Our fascination with Venus, the brightest jewel in Earth's celestial crown, has driven us to pierce its veil of secrecy for decades. Despite its proximity, unveiling the mysteries of this enigmatic world has proven to be a formidable challenge, pushing the boundaries of human ingenuity and technological prowess. The quest to explore Venus began in earnest during the space race, with both the Soviet Union and the United States vying for supremacy in this new frontier of scientific exploration. The Soviet Union took the lead in Venus exploration with its Venera program, a series of ambitious missions that marked humanity's first forays to another planet's surface. Beginning in the early 1960s, the Venera probes braved the intense heat and pressure of Venus's atmosphere, transmitting valuable data about its composition, temperature, and pressure. In 1970, Venera 7 achieved a historic milestone, becoming the first spacecraft to successfully land on another planet and transmit data from its surface. The United States followed suit with its Mariner program, sending spacecraft to fly by Venus and gather crucial information about its atmosphere and cloud cover. Mariner 2 in 1962 became the first successful interplanetary mission, providing the first close-up observations of Venus's atmosphere and confirming its extremely high temperatures. Later, the Magellan mission, launched in 1989, used advanced radar to map the Venusian surface with unprecedented detail, revealing a landscape shaped by volcanic activity and tectonic forces. While the golden age of Venus exploration may seem like a relic of the past, the quest to unravel the mysteries of our veiled sister planet is far from over. Today, a new generation of missions is poised to explore Venus with greater sophistication and technological prowess, seeking to answer fundamental questions about its atmosphere, geology, and potential for past or present life. Among the current flag bearers in Venus exploration is Japan's Akatsuki mission, which successfully entered orbit around Venus in 2015 after an initial setback. Akatsuki is dedicated to studying Venus's atmosphere, focusing on its complex weather patterns, superrotation, and the mysterious presence of phosphine, a potential biosignature. Its observations are providing valuable insights into the dynamics of Venus's atmosphere and the factors that contribute to its extreme conditions. As our understanding of Venus evolves, so too do our ambitions for its exploration. Scientists and engineers are constantly pushing the boundaries of what is technologically possible, envisioning bold new missions that will further unravel the mysteries of this enigmatic world. These future missions will require innovative approaches and advanced technologies to overcome the formidable challenges posed by Venus's extreme environment. One of the most ambitious concepts under consideration is a Venus lander capable of withstanding the crushing pressure and scorching temperatures of the planet's surface for an extended period. Such a lander would represent a significant technological leap, requiring advanced materials, thermal protection systems, and robust power sources to survive the harsh conditions. Its mission would be to analyze the composition of Venus's surface rocks, search for signs of past volcanic or tectonic activity, and potentially even look for evidence of past life. Another intriguing concept involves deploying a fleet of balloons or aerial platforms into Venus's atmosphere. In the grand tapestry of space exploration, Venus holds a special significance. As Earth's closest planetary neighbor and a world that may have once harbored more Earth-like conditions, Venus offers a unique opportunity to study the evolution of terrestrial planets and the factors that contribute to their habitability or lack thereof. Continued exploration of Venus is essential for advancing our understanding of planetary science, climate change, and the search for life beyond Earth. By studying Venus's runaway greenhouse effect, we gain valuable insights into the mechanisms of climate change and the potential for rapid and dramatic shifts in planetary climates. Venus serves as a stark warning about the potential consequences of unchecked greenhouse gas emissions and the importance of mitigating climate change on Earth. Furthermore, by comparing Venus's atmospheric evolution to Earth's, we can refine our climate models and develop more accurate predictions about the future of our own planet's climate. As we've journeyed through the turbulent atmosphere and across the scorching plains of Venus, one resounding truth emerges. This seemingly alien world holds profound lessons for humanity. From its fiery birth in the early solar system to its current status as a cautionary tale of runaway climate change, Venus serves as a beacon in the cosmos, illuminating the intricate processes that govern planetary evolution and the delicate balance that sustains life. Though shrouded in a veil of toxic clouds, Venus beckons us to unravel its secrets, offering invaluable insights into the workings of our own planet and the potential challenges and opportunities that await us as we venture further into the cosmos. We've delved into the depths of Venus's atmosphere, a cauldron of carbon dioxide and sulfuric acid that traps heat with unrelenting efficiency, creating a runaway greenhouse effect that has rendered its surface a scorching inferno. This extreme environment, while hostile to life as we know it, provides a natural laboratory for studying the dynamics of climate change, offering valuable data for refining our models and understanding the potential consequences of unchecked greenhouse gas emissions on Earth. We've explored the scarred and ancient surface of Venus, a testament to the powerful forces of volcanism and tectonic activity that have shaped this world over billions of years. The vast plains, towering volcanoes, and intricate networks of canyons and ridges tell a story of a planet in constant flux, shaped by internal heat and the relentless forces of geological change. By studying these features, we gain a deeper understanding of the processes that have sculpted not only Venus, but also our own planet, providing insights into the evolution of Earth's continents, oceans, and atmosphere. And we've peered through the veil of Venus's thick atmosphere, catching glimpses of its complex weather patterns, its superrotation, and the tantalizing possibility of phosphine, a potential biosignature, in its upper atmosphere. These observations fuel our curiosity, driving us to develop new technologies and embark on bolder missions to unlock the secrets hidden within this enigmatic world. Since the dawn of civilization, Venus has captivated our imaginations, inspiring myths, legends, and scientific inquiry. Its brilliance in the night sky, outshining all other celestial objects except the sun and moon, has earned it a special place in human culture, symbolizing beauty, love, and the mysteries of the cosmos. Ancient astronomers meticulously tracked its movements, weaving its celestial dance into their calendars and cosmologies, while poets and artists found inspiration in its ethereal glow, immortalizing it in verse and art. The invention of the telescope ushered in a new era of Venus observation, revealing its phases similar to those of the moon and providing the first hints of its thick and cloudy atmosphere. As our understanding of the solar system evolved, so too did our fascination with Venus, transforming from a celestial object of wonder into a target for scientific exploration. The space race of the 20th century ignited a fierce competition to reach Venus, culminating in a series of groundbreaking missions that unveiled its extreme environment and challenged our assumptions about our sister planet. As we stand at the cusp of a new era of space exploration, Venus beckons us with a siren call, urging us to venture forth and unlock its secrets. The knowledge we gain from studying this enigmatic world has the potential to revolutionize our understanding of planetary evolution, climate change, and the search for life beyond Earth. Now is the time to answer this call to explore, to embrace the challenge, and to embark on a new chapter in our quest to comprehend the cosmos and our place within it. Future missions to Venus will require boldness, innovation, and a spirit of international collaboration. We must develop technologies capable of withstanding the extreme temperatures and pressures of its surface, craft new strategies for exploring its dense and dynamic atmosphere, and devise ingenious methods for searching for signs of life in this seemingly inhospitable world. We must send landers capable of enduring the scorching heat and crushing pressure of Venus's surface, equipped with instruments to analyze its rocks, study its seismic activity, and search for clues to its past. We must deploy aerial platforms and balloons to drift through its turbulent atmosphere, collecting data on its weather patterns, chemical composition, and the tantalizing possibility of life in its upper layers. And we must continue to develop and refine our remote sensing capabilities, using orbiting spacecraft equipped with advanced radar, LiDAR, and hyperspectral imaging to map its surface, study its geology, and monitor its ever-changing atmosphere. The story of Venus and Earth is a tale of two planets, once potentially similar, that embarked on vastly different evolutionary paths. While Earth became a cradle of life, a vibrant world teeming with biodiversity, Venus succumbed to a runaway greenhouse effect, transforming into a scorching, inhospitable wasteland. Yet despite their divergent fates, the stories of these two planets are inextricably intertwined, offering profound lessons about planetary evolution, the delicate balance of nature, and the shared destiny of all life in the cosmos. Venus serves as a stark reminder that even planets located within a star's habitable zone are not guaranteed to be hospitable to life. The delicate balance of factors that contribute to a planet's climate, its atmosphere, its geology, its distance from its star, and even the influence of other celestial bodies can be easily disrupted, leading to dramatic and irreversible changes. The runaway greenhouse effect that grips Venus today is a cautionary tale, a stark reminder of the potential consequences of unchecked environmental change. While Earth's current climate is far more hospitable than Venus's, the lessons learned from our sister planet underscore the importance of environmental stewardship, the need to reduce greenhouse gas emissions, and the urgency of addressing the challenges of climate change. As we gaze upon Venus, a brilliant jewel shimmering in the twilight sky, let us remember that it is more than just a celestial object. It is a mirror reflecting our own planet's past, present, and potential future. In its fiery embrace, we find inspiration for scientific inquiry, a renewed appreciation for the fragility of our own world, and a call to action to protect the delicate balance of life on Earth. The lessons learned from Venus will continue to guide us as we venture further into the cosmos, shaping our understanding of planetary systems, informing our search for life beyond Earth, and inspiring generations to come. Let us therefore continue to look to the sky, to seek knowledge from the stars, and to learn from the enigmatic beauty of our sister planet, Venus. For in its fiery heart and turbulent atmosphere lie secrets that hold the key to a deeper understanding of our place in the universe and the future of life itself.